Hello, my dear students of class 9. Today we are going to continue with the chapter Concerns about our environment. So, in our last class, we were learning about the various layers of atmosphere. Now, beyond the exosphere, there is practically no air. It is reduced to a vacuum. Variation of pressure with altitude. Normally, the pressure of the atmosphere is maximum at the lowest layer and it decreases as the height above the Earth's surface increases. At the ground, the air pressure is about 1.013 atmosphere. Now see the relationship between 1 atmosphere and centimeter. 1 atmosphere equals to 76 centimeter of Hg or 760 millimeter of Hg. Hg means mercury. Now table 1.1 shows the variation of pressure with altitude. Altitude means height. See, in tropopause the pressure is 10 to the power minus 1, that is 1 by 10. In stratosphere the air pressure is 1 by 1000. In mesosphere it is 1 by 10,000. So as we move higher up, the air pressure decreases. Alright. So convection, currents and storm. The air adjacent to the Earth's surface gets heated first by sun rays. That is, the air which is closest to the Earth's surface, that air gets heated by rays of sun. On being heated, it expands and becomes less dense and rises upwards. While the cold air from the upper surface that comes down and takes the vacant space. Vacant means empty space. This action sets up the flow of air, which is called convection currents. You have learnt about convection currents in your junior classes. This also takes place in atmosphere. In liquids and gases, heat is transmitted by convection as their molecules are quite free to move about. On the other hand, molecule in a solid being closely packed cannot move like molecules of liquids and gases. So convection current does not occur in solids. All kinds of wind are caused due to uneven heating of earth. When the air moves with a high speed over a surface, it results in decreasing pressure. Thus, strong winds start blowing from high pressure area to low pressure area, resulting in storm. You have learnt about how the storms are formed in your geography class. Alright, that is, when winds start moving from the area of high pressure to the area of low pressure, it causes storm and accompanied by heavy rainfall or violent outbreak of thunder and lightning. Thus all storms are low pressure systems. So remember convection currents, how it is formed and how storms are formed also. Okay. Next we are having the ozone layer. In the further region of the stratosphere, there exists a layer of ozone gas called the ozonosphere. This layer absorbs most of the harmful UV rays coming from the sun and protects life on Earth. Now, how ozone layer is formed? Ozone or O3 is formed in the upper atmosphere by a photochemical reaction of O2. That is oxygen. The oxygen molecules breaks down to atomic O by absorption of UV rays, and then each O atom adds up to an O2 molecule in the presence of nitrogen or oxygen to form an O3 molecule. See how it is forming. First, with the help of UV rays, O2 breaks down to O plus O. Then this O plus O2 reaction takes place. That is, each atomic part of oxygen reacts with O2, that is the molecular part of oxygen, in presence of nitrogen or O2 and forms O3. O plus O2 gives O3. Next we have destruction of the ozone layer. The main cause of the destruction of the ozone layer is the release of chlorofluorocarbons. You already know that by its high rate use in refrigerations, air conditioning and aerosol sprays, and also by nitric oxide and nitrogen dioxide. The thickness of ozone layer is thus reduced. The thinning looks like a hole called the ozone hole. This was observed by the scientists in 1980s over Antarctica. See, a picture is shown in figure 1.2, ozone hole over Antarctica. Now, role of CFCs in the ozone layer's destruction. How CFC takes part in the destruction of ozone layer. CFCs are comparatively inactive in the lower atmosphere but highly reactive in the stratosphere, where they give free chlorine as free radical. Chlorofluorocarbons, chlorine, alright. They react with O3 to convert it into O2. So the chlorine part of chlorofluorocarbon reacts with O3 and converts it into O2. In such reaction, ozone layer gets depleted. Now, role of NO and NO2 in the destruction of ozone layer. This is very important. See the reaction. NO plus O3 becomes NO2 plus O2. So O3 is changing to O2. This O2 gets reduced to atomic form of oxygen O in presence of UV rays. So O2 breaks down to O plus O. Now NO2 again reacts with O to form NO plus O2. So nitric oxide reacts with O3 to form O2 and nitrogen dioxide. The oxygen molecule breaks down to atomic O by absorbing UV radiation. NO2 reacts with atomic O and forms NO back. So the amount of NO remains same. See, we are getting back NO. We started with NO and we are getting back NO. But as a result of this, O3 molecule gets decomposed. In this way, ozone layer is destroyed. So effects of ozone depletion on living bodies. Ozone depletion causes sunburns, skin cancer, cataracts and other infectious diseases. So I hope you have understood, children. Please go through the part of this chapter as much we have done. We will continue with it in the next class. Thank you, children. Stay safe at home.